So welcome to this afternoon's session. We have two sessions this afternoon. First, looking at our work in decision making, predominantly in three waters, and then looking at our new theme 4, which is around environmental sustainability. But we also have the opportunity for Robert, because he had to sneak off, to come back and just cover his last bit on digital consenting. So we'll do that, if that's okay, between the three waters and the last session with Larry. So the three waters theme, it has a number of projects within it. First up, we're going to have Professor Matt Wilson, who's the director of the Geospatial Research Institute, to talk about some work we're doing in the digital twin for flood resilience, working with a local council here. And then we will be looking at Dr. Theuns Henning from Auckland, who will be talking about our other decision-making framework, and Chloe Pancheri, our research engineer, will be talking about a certain aspect of what we're doing in the pipe data portal and digital standards between waters. So, without further ado, if I can drag you from your cup of coffee, Matt. You're first up, yeah. Cool. First, sorry. 10 minutes.
Hi everyone, really nice to see you all. Some of you might have seen this before, might be new for some people. But I have the pleasure of working on this project as part of this program, where we're really developing, calling it a digital twin, but it's really a system which enables us to automate a flood modelling and flood risk assessment process. And first thing I'll point out, you've probably heard of the National Flood Programme run by NEWA. So this is actually part of that programme. So the hope is that the system that we develop will feed into the automation of flood risk assessments at a national scale. So I'll come back and say all of that again as we go through, but I'll introduce you to what we've been doing. And really the key thing, work this. Okay. The key thing is that whenever we do any kind of risk assessment, we have to deal with a key challenge, which is that it requires an enormous amount of data. So those data are related to the built infrastructure, in terms of assessing what the impacts are to buildings, to roads, and so on. But they're also in terms of actually predicting where will be impacted. So we're looking at where water will flow across the land surface requires a lot of data to do with things like topography, but also things like drainage infrastructure and actually how much water is in there in the system in the first place. So rainfall, river flows, that sort of thing. So we need to bring together all these data, integrate them within some kind of system or connection of systems, and then do the analysis to be able to produce information which can be then used for decision making. So that line of analysis, that pipeline of analysis is actually quite complex and requires lots of data. And what we're trying to do is streamline the whole lot, so that an end user, a stakeholder, could be a decision maker, can get information at much quicker, ideally in close to real time. So reacting to new information that is provided by in-field observations, for example, to be able to get updated scenarios or much more scenarios, you name it. So this is our sketch that we did back a couple of years ago nearly, as we were putting together the conceptual ideas of the project, and really illustrates just what I've been saying. So on the left-hand side, we have a whole load of data, which feeds into, what we're trying to do is transform that data into a flood risk assessment on the right-hand side. So the bit in the middle is illustrating what we're trying to do with it. So we ingest that data into a system of databases, transform that into a hydraulic model, run that model to get predictions of inundation extents and depths and flows, and then analyze those outputs for various different scenarios to look at the impact. So we bring in things like where the buildings are located, the type of the buildings, and so on. So I guess the key thing really, like I said already, is that this is an automated process. So if we can automate it, we can solve that challenge that we have of having, we're drowning in a sea of data essentially. And this will enable a lot, much more rapid risk assessment, and therefore more risk assessments to be done. So the more scenarios we can run, the more we're able to get fine details within those risk assessments. So rather than just having one scenario run, because that takes so long to do, we do things much quicker, we can have multiple different scenarios, for example. So what I'll do is I'll take you through our progress towards creating this. And our study site that we selected is Kaipoi, which is just north of Christchurch, not far away. And we selected it, I won't say it's easy, but we selected it because it's easier than choosing a large site, and because it has some decent data associated with it as well. But it also has substantial flood risk, so it makes an interesting case study. It has risk from multiple different directions too. The Waimate River, huge river there, which causes it flood risk. The Ashley River is just off the map to the north as well. There's risk from that, from breakout. So you can get some backflow from the Waimate River into Kaipoi. You can also get backflow from the tide. So you've got downstream flood risk as well. And then you've got the fluvial kind of events. So the flood risk from across the floodplain through the Kaipoi River, which flows through the town, and then a direct fluvial as well. So like I say, what we want to do is create this digital twin. We're about halfway through the process of that. And once it's done, deploy it at a national scale. So be able to automate the risk assessments across the country. That's quite ambitious. But we're on that road towards that. So just to illustrate what this does, just not in any detail, but in just a little example, one of the things that it generates is one of the key things is a model grid. So a model grid representing the terrain, the heights above sea level of all the different locations within the floodplain. And of course, not surprisingly, that controls in a strong way where water flows. So it's important that we get that as accurately produced as possible. And so therefore we use LiDAR data. So that's a point cloud data set. But that point cloud data set can't just be fed straight into the models that we use to run, to predict the flood inundation. We need to first create a model grid. So we need to process those data to create that model grid. And so we're using a library that's been created as part of the national program and this digital twin called GeoFabrics, which is essentially processing the LiDAR data into a hydraulically conditioned model grid, which essentially means that we have the bare land surface and we control things like the drainage network. So the drainage network is represented in a realistic way within that model grid. And we've removed features such as vegetation from that. So obviously the water's not going to flow over the top of the vegetation, it's going to flow through it. So we represent vegetation in terms of friction rather than in terms of topography. So that's one example of what we're doing in an automated way. Once we have that, we can then generate, given some scenarios or perhaps some observations in future, we can generate realization of inundation. This example is a rather extreme hypothetical scenario for a fluvial event. There's only rainfall going, and then we're using this as a test. So you can see that as it rains, of course, the model is filling up certain areas where lower lying areas are becoming more flooded than the higher areas, and we can visualize that. But going from that, so that's generated the model, we run it for a particular scenario, we can then ingest those results, or perhaps the maximum extent and depth of from that scenario, ingest those results and do some analysis with it. So a couple of simple examples here. Which buildings are flooded and to what depth? what's the impact across that location? Where should we be targeting resources to go and investigate, or to during an event, or insurance purposes after an event? What about roads? Are roads passable? So one of the workshops that we had, a requested output from this would be a real-time prediction of which roads are passable or not, so that we can have traffic routing and warning signs and things like that. That's feasible. That's a stretch, but this is a sort of illustration of what we might be able to produce. So we can say, okay, these roads here have some water to a particular depth. How deep is too deep? Does the road need to be closed? That sort of thing. Any kind of geospatial analysis of the mole results is possible within this as well. So there's opportunity here to give feedback and contribute ideas for actually what is it that's needed from the outputs. We're also doing a front end. This is in early stages. This is just a mock-up. We focus on the back end largely, but in developing the work, we realized that actually we need to have some fancy graphics as well to illustrate what we're doing. People like to see the fancy stuff. Although actually the back end is a lot more, for me, a lot more interesting than front end. So here you're just seeing building size in red if they're over 10 centimeters of water depth around them. Of course, you can change that parameter and visualize it in different ways. And really the idea here is not to have a full-blown visualization of, like you've seen those digital twins online that look like reality. We're not trying to represent reality within our 3D visualization here. We're trying to represent in a reasonable way to inform people about that particular scenario. So work in progress, but quite like it so far. Cesium is being used because it's quite well supported for digital twins. That's the Cesium library. But also another thing that we're hoping to do in future is to connect this into VR and AR. And Cesium has connections into that as well. So you can imagine that you're standing in a street or on a stop bank and visualizing in AR on your phone various different scenarios that are within this. So next steps. This is kind of where we're heading. This sort of system down there, we've got a Docker container, which is wrapping everything up, which should allow easy deployment. We're looking, at the moment, we're working on the first one there, additional inputs and standardized scenarios. Working closely with the NEWA team on what scenarios they're going to be using, but we're also bringing in additional scenarios as we go too. And there will be opportunity to develop those further as we move forward. So we'll have a set of standardized scenarios at the outset and then develop from there. We don't yet have that connection to RISC-8. That's one of the requested connections. So that's one of the widely used tools to assess impacts given a particular scenario. So we'll have that connection created. That is that's possible because there's an API for RISC-8 that we'll connect to. One of the things that we've been given feedback for and we've taken on board is that we'll have an API created for this. So we started work on that API. So that allows organizations to bypass the front end, fancy graphics, and connect their systems to the back end of the digital twin to pull out the information that's in there or generate new scenarios as needed. So we started working on that because the front end that you've seen is actually using an early version of that API to put information out. So we've already got underway. And we will have a front-end user interface to some extent. Really, I think primarily for public engagement more than anything, and to illustrate what we're doing, and perhaps provide some control over visualizing and analyzing the outputs, but feedback welcome on that. Looking a little further ahead, so really this is beyond this project, although we might be able to pull some of them into it. We'll be connecting to the stormwater network. One of the limitations of the modeling so far that I didn't say is that we don't have a stormwater network in there. That's quite challenging to bring into that modeling in an automated way. But so we're looking at doing that. But it's probably for more than 12 months out, really. That traffic routing, that's an ambitious target. I think we'll aim for that. Also, the user-defined scenarios, either through the API or through the front-end interface, would be great to be able to have users tweak or run additional scenarios given their own data or their own analysis, and have the system generate the results for comparison with standard-based scenarios would be something that would be excellent to do. Additional methods through things like ML is machine learning. So if you run a whole load of different scenarios through a library of scenarios, then you can generate through machine learning a prediction of what is likely to be the impact given a new scenario, given that from that library. So the idea really is to use that library of scenarios to generate more quickly a new realization. So every time we run a model, that takes a lot of computation, and it takes a few hours to run. So in order to be able to provide an instantaneous result or near instantaneous result, we need to do something a little bit more clever than running model every time we need to get a new scenario done. We're also going to look at developing a cloud-hosted service, although the software is available for anyone to download and deploy in their own systems. So we haven't got very far in investigating that, but I think it's probably likely. And then also connecting to other digital twins. So there's a lot of momentum, maybe, or at least noise about digital twins within the country, the national digital twin movement. I think my opinion, and a lot of people seem to share this, is that rather than having one big digital twin for New Zealand, we need to have multiple digital twins that talk to each other. And so that means standardization. And so I've put that up there because I want to see that happen. But we need to have a bit more work about how we do that over the next however many months. So we've got, we had great input from industry. Thanks to everyone who's been involved in those workshops so far. That's really helped to shape the direction of the work that we're doing. It's stretched us a little bit as well. And we've got a timeline that goes beyond the end of the project, but we will be looking for additional funding to enable us to actually put that into reality. I guess one of the key things, like I said already, is that that NEWA-led program, I'm part of that as well, and several of the team members are as well. So we're sharing the methodologies and the data that are used. So my hope is that come the end of this, and perhaps when that NEWA-led program comes to an end, the whole point of that program is that it's not an endpoint where we just say, okay, plug this is done, check for New Zealand. That's never going to be the case. We need to rerun the models and generate new scenarios if better data comes in, or as more information about climate change comes in, that sort of thing. So this should help to underpin that repeated analysis over the next 10, 20 years as we move forward. I've said all this already. Really, I guess one of the things I'd highlight there that maybe didn't say is number 4. This is all open source code, so you're welcome to go download it. It's being polished a bit, so it looks all right at the moment. Of course, it's not complete, but the idea really, by making it open source, freely available to all to use, is that you can actually build from this in different domain areas, perhaps, or even in the same domain area. You're welcome to go and see how we've done things exactly. The point is to be transparent about everything. So yeah, and I think the last one, oh yeah, it's on GitHub, so there's the link. Feedback welcome. Feel free to find bugs and submit issues. We found quite a few. We're expecting to release a beta release late this year, maybe into early next year. And by beta release, I mean the system is fully functional, albeit perhaps with some things that are not yet implemented, but it will be a system that enables you to draw an area of interest on the map and then spin up a model and get the outputs of that model for a standardized scenario. And also, if you want to contribute some code, you're very welcome to do that too. But otherwise, yeah. All right, I don't know how long that was going. I'll leave it there. Slightly over. There we go. Glad you think so. You're part of the project.
Matt, you know, first slide.
First slide.
Very first slide. You know, onboard data.
This one or this one?
This one. Yeah. This area. One of the things that we're doing, third, but close to see, looking to automate all that piece out. So we're going to get groundwater right across. Who did that in there? I could see it.
Might not have been it.
Because that is huge effects on.
Not exhaustive either.
The catch-all.
Be great to add that in. Thank you.
We just have a couple of minutes for questions.
I think I heard you say you hadn't considered stormwater, but I'm just wondering if you've considered the impact resulting from land use intensification on permeable soils and what effect that can have. For example, if you look at a suburb anywhere in Christchurch, hypothetically, looking 10 years out and suddenly seeing massive intensification, you haven't got those natural areas absorbing rainwater, they're going into stormwater. I'm just wondering if is that something you're going to look at?
That's a great suggestion. That's a scenario, so sort of natural flood management, we might call that. We have the reverse of the intensification, actually produce areas of absorb water. Would be great to test those within this sort of system. So we have considered stormwater, it's just that we pushed it out because of the complexity that is needed. So we'll be doing that. But that scenario type thing, absolutely, yeah, that can be included. Thanks for the suggestion.
There's a lot of confused when it said it's about onboarding the stormwater systems. Because in the previous slide, I'm not a hydraulic modeler, but I have built models, 2D models within some of our design software and using the two-flow engine. So I've been coupling overland rain events with wastewater networks for pipe size and everything. And I've seen some quite large examples where it's just put in as a 3D model.
Yeah.
And all the basic hydraulic calculations of impact control, outlet control, etc. So
how are we going to do it?
Well, no, it's just a case of I'm just a little, I don't know. How you say it's hard to get the stormwater model in?
Automatically. That's the automation's the key thing. So one thing I didn't mention is we're using the BG flood model, which is the one that's being used by NERA nationally, but it doesn't include stormwater.
Right.
But you can see that we're feeding into that program, so that's the rationale behind that decision. Okay. In order to include stormwater, we need to swap out BG flood and bring in two-flow or some other model that will do stormwater. And you've got two models being coupled there. You've got the pipe network model and the surface water model being connected. So it's a non-trivial problem, but it's certainly one that can be solved.
I would also, Mike, will either disagree or not, but okay. I will also include the wastewater because Christchurch City wastewater actually does contribute an awful lot to the dissipation of floodwaters right across the city.
Absolutely. Yeah, I mean, this has been pushed back to the national programme too. And the response generally is that this is a national model that's being produced, one that is going to provide like a synoptic picture about what the risk is, but it's not going to replace the local models that are already being run, which are much more detailed. The aim is not to replicate, the aim is to produce a picture that has that synoptic risk. But you will get better models as you go towards the local level, those being run in councils. But at the same time, I think there's a desire to bring in that stormwater system as well.
We've tried mixing a flood model with a pipe model for stormwater layout. Stormwater is particularly hard because it's not a constant liquid. But
wastewater, once it's in the pipes, it should stay in the pipes, but stormwater, you've got all the bubble up sumps, culverts, ozone comes out of here. It's really complicated.
Thank you, Matt.
All right.
So, cool. Thanks very much. We did, we're a bit time constrained. What for the next? Oh, it's on there. It's here. Thank you. So I will pass you on to Theuns and Purvi.
There we go. Thank you very much, Greg. Okay, so normally because we theme one, we go first. Today we go last, and that's all good. I understand the time different issues. So I just want to acknowledge the team members in this theme. Greg, Perry, and we've got Purvis online from the University of Auckland, and today we're just going to give you sort of a brief update of where we got to with the various projects, and then focus a little bit more on where we're going with the future development. So just a refresher, the four core areas that we are working in and all aiming towards better decision making, starting off with 3 waters. But I think the dream was always to expand that to other infrastructures also. First one, quality data, understanding the pipe performance a bit better, decision making, and with particular focus on well-being, and then the delivery and procurement aspects. So for the first and the fourth one, we have concluded the white papers as a starting point. Those projects didn't progress further into active projects, except we are now getting back to the data collection side of things in that first one, and we do have a couple of very exciting projects on the books. So in terms of the reporting, we're going to mostly focus on the pipe portal today and also the decision making. Also just acknowledging sort of the drivers and where our impact is going to land. I think all of you are well aware of the water reform, and that of course created a significant opportunity for us in terms of implementing some of the things that we have developed. Also acknowledging our partners, CODAP, Rata in the Waikato area, IDS in the modeling area, and then Harmonic Analytics in the data quality area that Purvi will talk about in a moment. So first one, providing quality and consistent data. So that has focused on the data collection process, in which we did the white paper, data standards, also developed the New Zealand code of practice. On the back of that, developed the data portal, and we've got a map there on the right-hand side. And to date, we have already mapped 32 councils in New Zealand to common data standards. Through the work of the DIA, there are some discussions about the future data standards, but the value in what we have done is really in the dictionary. So you can have any data standard sitting in the back end to map to that is then pretty straightforward. And then a project that started off later and has fantastic results that Purvi will present is the data quality tool. So I'm going to ask Purvi to take you a little bit through that, because she has done most of the heavy lifting in this development. Thank you, Purvi.
So hi everyone, myself Purvi Pancholi, and thanks Steve for giving me the opportunity to give the demo of our work with the National Park Conservation. So as we all know, our asset owners and asset engineers from all 3 waters network connect the data for the management of their assets. And we have 67 councils in New Zealand, and different councils have different way of collecting their data. So we needed the way of collecting their data and standardizing in a form that we have, like, integrated system. So this is where the story started for us. which is the story about national park data portal. We designed the pipe portals, standardized format, which is code of practice for clean waters. And then we started collecting the data from different councils. So the map on the right hand side of the slide shows the number of councils across the New Zealand. We collected the data, and now they are in our pipe portal, and we are looking for some further analysis on it. So the top part of the slide shows how we extract the data, transform, and put it into a system. So we are right now collecting councils expert data from different councils. So the source 1, 2, and 3 are like name of the councils, for example. And then we use the transformation using tool FME for transforming those data into the standardized format. And then we create the database and save those data into a data set. And the bottom part of the slide shows the outcomes of this project, which is more, and the really good part of this, it is the data quality assessment tool that we have created out of this pipe portal project. So let me take you through the actual demo or dashboard where how we have created this tool. So this is the data quality assessment tool that we have designed, and we are analyzing this using 4 data metrics, which is more on looking at the accuracy of the data coming, the completeness, compatibility, and code of practice alignment. Where for the accuracy, we are looking for the data, how true the data are coming into our system. As in, for example, if you look for the inward level of the pipes. So obviously for gravity pipes, and if they are stormwater or wastewater coming from those networks, from node inward level should be greater than 2 node inward levels for the gravity pipes. But there are some data which is coming from different councils where it's opposite. So this kind of accuracy from the data which we are looking into, as in doing the analysis. The completeness part where we are looking for how the data is coming, the attributes are showing the correct value or not. Sometimes the councils are not collecting, or they are having no data for some important attributes. So this is what the completeness parts look into. And the compatibility is the compatibility with the code of practice, because it's a standard form. We wanted the data in the form of having correct data type and correct value. For example, we have created the data dictionaries out of this process of pipe portal, where when the data comes, we create the data dictionary out of each of this data coming. So we have those dictionaries for asset levels, asset attributes, and codeless levels. So for example, if the material coming from council is saying concrete, in our system it's CO and C. So the data should be transferred into that format, which is readable or in the integrated format. So this is what the compatibility and the alignment with the code of practice is. And the strip on the bottom of the slide shows the actual score versus the target score of any of the councils. So this is just a dummy councils example. And the practice gap is something which councils can reach with this data quality tool. We have incorporated around 17 councils into our data quality tool. And yeah, this is across all over the New Zealand. And if you want to have a detailed result of this analysis, we can look for any water service type. Say, for example, if you want to look for water supply pipes and just want to look for the analysis for pipes, we can just click into it and look for all the data metrics which we have created. And the beauty of this dashboard is that we have all the description of what I was explaining you about the data metrics, and we can download the scores of councils for any specific councils data. So this is really a useful tool for us for having the data quality assessment. And
sorry, you can't see the dashboard, so it stopped. I've just seen on my screen. So
is it online?
I've just got the slide showing on the dashboard. Does it show
Okay,
on the
because
presentation? Yeah, they share the presentation.
okay, so how do I share the full screen? Share. Yeah. So quick enough to show, right? Should I demo it again, or it's fine?
Just click back really to.
Oh yes, so it's just the
show
summary
some
part.
results.
Yeah, where it is showing all the metrics. Yeah, and obviously, we can come across with different councils when we collect the data. Yeah, so if I'll jump back to the presentation. So we have now the quality essence for the data. I think I shared the screen. Oh, okay. Right. So now we have collected our information about the quality of data. And then we wanted to check it live, as in like, creating those queries live and see actually in the network where those pipes sits in. So here comes the beauty of our geospatial spatial pipe data portals dashboard. So we created some queries out of it. As I said, we have to have a look for those queries. For example, where for the gravity pipes, we want to look how many of those pipes in a specific network where that from node invert level is less than 2 node invert level, or think of the unique IDs are not unique, or the asset IDs are not unique. So here are some quality issues with the data we have. Or for example, the material installation here are not correct. We have some pipes where the asbestos cement pipes are installed in 2018 or 2030, which is something theoretically not matching with the material and data of construction of the commission of those assets. Or some of the council's data, they have decommissioned date before the commission date. So this is something, a question for us to look into. And it's good. The beauty part of this is like, we can check or view it online. And let's see. So can you see the pipe portal, right?
Yep.
Okay. Yeah. So this is again showing the same map of all the councils across New Zealand that we have interacted with. And I have created some bookmarks for these questions. So let me go straight to, those queries. And I'm flying to I think it's DCDC, so it's a Theuns District Council. And it is popping up some of the council's pipes where they have from node invert level, which is less than the 2 node invert level. So if I'll just click on one of this pipe, it will give information about the stored information about this specific pipe. So it's not working too fast on the network. So yeah, this is a pipe from Theuns Coromandel, and yeah, so let's see their invert levels. So obviously that 2 node invert level is 3.11 versus from node invert level is 2.66. So either this pipe is going uphill or this is something data quality issue. So this is what the question, we can do it live on our pipe portal. The second question, if I'll fly now to the Hamilton City Council. So I have just taken example across the New Zealand to see some of those queries which we have created. So now we are flying to Hamilton City Council and looking into issues with the unique IDs, where pipe, not only one, so there are 2 or 3 pipes having the same unique IDs. So I grabbed one of the example. So let me show you the information of this pipe. And it says, this is from Hamilton City Council, and the unique ID for this pipe is 308021. And I checked the same system and looked into the second pipe having the same unique ID. So if you just look again, this pipe's unique IDs are 308021. So this kind of questions are very quick to find. And in the same way, I created a query where we are looking for material versus the installation year. So again, I'm flying here to the Oturanga District Council to show this example of the pipe. So yeah, let me show you one of the example here. And yeah, so this is Oturanga District Council, where if we look for the installation year of this pipe is in 2018, but the material is asbestos cement pipe. So this is something fishy, because asbestos cement pipes were installed in New Zealand are in between around, the threshold is 1990, I would say. That's what the theoretical threshold value say about the asbestos cement pipes. And the last query I created was about the commission versus the decommission rate, where I'm flying now again to the Hamilton City Council to see one of the example of the pipe. So if I click on this pipe, give me information about what it represents. So for this pipe is in use. it's not abandoned pipe, but the construction date or the commission date of this pipe is 1960, and the decommission date is in 1899. So this is something going crazy. So this kind of data quality assessment can do a live query on our portal. Yeah. So the other part of this portal is the data analytics stuff, and I think things will present more in detail those things. Yeah.
Thank you very much, Kirby. Appreciate that. Okay, so obviously the end goal of having the good data is then ultimately to do something with it. One of the things that Kirby has started off with is just reporting out of the portal in Power BI. But then as we continue, I'll show you a little bit more in terms of how we're going to intend using some of the information. Good. Now getting on to the project, the forecasting of the life expectancy of sewer pipes. And this is one of the areas that's been led by Professor Kobus van Zyl out of Auckland. And the areas that we are covering in that is the interpretation of CCTV data, sewer pipe failure definitions, the factors that impact on those failures, and then developing ultimately a forecasting model for that. The initial work was very much focused around the different defects and failures, and we couldn't find anything consistent in that from literature. So one of our first outputs was this paper that looked at a consistent classification system for sewer pipe deterioration and the asset management space. That, of course, is going to give us the foundation for our condition code of practice, and will assist with the CCTV defect identification and then ultimately into the model development. So really the system looks at contributing factors towards failure, stuff that's really not failure yet, but can be classified as a defect, and then those items that we know has been failures of the pipe system. Our methodology in developing the deterioration models started off, and what we have completed was just using simple linear regressions to understand how the different factors influences on pipe performance. That is now going to go into a little bit more of the sophisticated modeling techniques, including machine learning, but we really set the foundation first of understanding at a fundamental level how the pipe's performing. This is done through a research PhD project that is now almost 2/3 into the way, so we're getting towards the end of that. The next exciting bit is on the decision making and using the living standards framework. We've got Eric Barnes here. Eric did his master's in completing a performance framework from this work, which is now tipping over into his PhD, looking at the physical decision making process. So that first point has been completed, the performance monitoring framework, looking at both pipe condition information and the well-being data coming in. So that data set has been created for the Waikato region, and Kirby and their students put in quite a bit of work in that and worked through masses and masses of data on that. And now we're going to get into the exciting analytics parts of it. So we hope to be putting a framework on the table that's going to be very powerful. And really the intent behind this is to know when we do an investment into our three water system, how is it impacting on our community? And this is a trend in the asset management space that is all over the world. The day of simply doing economic analysis is over. We need to start looking at our community outcomes. We need to start looking at our carbon emissions, and we need to start looking at our resilience aspects. A specific focus that we are going to have is around Te Mana Otiwai in New Zealand, in bringing in the both a Maori value system, but then also a lot of that indigenous knowledge in the decision making. There's some fundamental principles in Maoridom that I, as asset manager, admire. The long term, making decisions for my grandchildren's grandchildren. If you do the maths, that's about 100 years away. And then also that holistic way of making decisions. We've mapped our framework to the UN Sustainability Goals. We've presented this in a conference in Sweden or Norway, Sweden, I think. And we were quite pleased with being honored with the Best Paper Award. So we're definitely on the right path with that. Next project is a master's that was completed, or is in completion at this moment, that looks at water resource planning, assessing the value of water and in particular drought and resilience aspects. This was done with the help of Wellington Water. And what we want to be able to do is looking at prevention of drought restrictions and balancing that off with the cost of investing into preventing those restrictions coming into play. This is a serious issue around the world, so we've picked up, especially in the UK, where they're lifting their standards or level of service to much more longer term periods for drought prevention or drought restrictions. And in this research, we particularly looking at different ways of calculating the cost that then contributes. So what we have here are the two lines I've been talking about: water supply investment and then the drought cost. Now that drought cost is made up by all these factors, and that's where the bulk of the research was in. And then ultimately, if you get the sum of those two, you can minimize the overall system. Righty, getting on to the future projects, and the first exciting part is really progressing towards that national digital model that was our dream from the beginning. Working on this well-being decision framework that I've already discussed. We've got a new project in harnessing a little bit more data collection techniques in the sewer pipe system, and then the implementation of decision support using the data that Theuns has just presented to us. So the first one, a decision framework that is in development. If ever you played the game SimCity, this is basically what we want to create, is a simulation that shows investment in the water sector and how it then impacts on your different domains in the well-being framework. We want to also link up with other research. We've got research connections with the research donators challenge that looks at the same sort of scenario, but more from a resilience perspective. Also bringing in the decision making from indigenous perspectives, particularly from the Maori perspective. And we have picked up what I see a really good piece of work that was done by Landcare that starts to understand the principles that we want to bring to our decision making process. At this stage, we are looking at partners with different EVs to help us with this part in particular. Right. Then the next one is extracting the value out of CCTV sewer pipe inspections. Now, there was a discussion earlier here today of getting a little bit more AI involved with our pipe inspections. And what we really try to do with that then is taking it to the next step to give us that knowledge and insights into how these defects develop over time, and then also to help us with making the decisions around the maintenance and replacement aspects of the sewer pipes. This project is in tandem with another project also at this stage with water care, but we are looking at other councils to partner on this project, is to understand the condition from pipes that's in the field when they do maintenance, when they open up the pipes, is to take samples and to learn from that. And we all know the work that's been done in Christchurch by John Black over the years of doing just that. So we want to expand that work and take it a little bit further. Again, aiming towards understanding the cost-benefit trade-offs in condition and pipe replacements. And then another project that has started already is in partnership with RES. We are looking at taking the data portal information that's quality checked and quite robust data, and then run it through a forecasting and optimization tool that has been in New Zealand for a number of years now. And really the intent there is to optimize your renewals and replacement investment across your water network. And there's some output examples, investment scenarios that you can investigate, and from that you can get your forecasted performance of your pipes, both in terms of pipe condition, but also grade rates and those sort of things. Right, so I think we are very pleased with the progress that we've made. We're also equally grateful and working with our industry partners, and we believe that our projects are making an impact, and hopefully in the future will do so. That's just extra slides. Thank you.
Awesome. I have two-part question for you. I'm totally aware of your work. I'm a big fan. I'm fangirling out right now. So my two-part question is, number one, just a statement about the standardization of attributes and attributable data. Fantastic. As you know, we've been struggling this for many years with people calling a spade a scythe and all this kind of thing. So it's really nice to have that. The two-part question is around geotechnical data and pipe monitoring data.
Yes.
So number one, it would be, is it a thought process currently to include the geotechnical data? So where the pipes, what is the geotech that those pipes are buried in and around? It aids us when we go through and we do our spot inspection work, and also when we go through and do some other stuff. It also aids in the sciences that we use in this place as well.
Yeah.
So that's the first part of the question.
Yes. Okay. Not at this stage, but I think, as you're well aware of, pipe performance is very much linked to your geotechnical aspects and also your moisture fluctuation.
Absolutely.
So I think it's a logical next step. So where we're at now is we've got all the inventory data and data quality checks around that for pipes and for the associated asset groups. We now next onto the condition information. And then once we've got the condition information in, I think we need to have a hard look at what's next. And I agree that geotechnical data is something that's essential, especially in that platform.
We've listed it as part of our process as well, but also in product development that we're working on internationally with our technology companies.
Yeah.
This is a major factor because we're automating the algorithms regarding the geotechnical space as we're working in and around that. So
Cannot agree more.
Yeah, cool.
Okay.
Second part of the question, pipe monitoring data.
Yeah.
So now we have our smart monitoring technologies on the pipes themselves. They're monitoring different stuff going on with the pipe.
Yes.
Have you thought about how you were going to link the data coming from the pipe monitoring into the data sets within this particular
Portal?
Yes.
Yes, so that is something that we are currently working on. So basically, in terms of condition data, you've got two types. You've got your snapshot in time type information. So it is maybe an inspection that comes in and the data is dormant for quite a while until we do something again. But then you get continuous data feeds that's coming in also. And typically in the asset management space, what we do with that is you get sort of a rolling average value that sits there, but then where that data becomes valuable is when it spikes, and that is additional information. So the moment that something deviates from your expected or norm data, that piece is then reported and time stamped. So yeah, so we are looking at how we're going to address that information. The one thing that is in decision making very important, of course, is things like when somebody goes out and do work, and for that information to come back in again, and there's a whole lot of automation that's needed for that.
Great, thank you so much.
Mike is next. He booked the spot in lunchtime.
This is my area. So I get
Just-
all
The folks remote were also requesting if the question answers could identify themselves before asking the question. So hi, Mike Lambos, Christchurch City Council, very much active in this area, which is why I warned Theuns I'd be a heckler. Now, you've been working on this for a number of years. I've been doing the same thing at Christchurch City Council for 5 years now.
Yeah.
I know WSP's developing their own framework, GHD's constructing a framework, Becca's constructing a framework.
Yeah.
How do we bring all the expertise together?
Are you referring to the decision making framework?
Yeah.
Yeah. So, I mean, that had on today the discussion around IDS, but IDS is a membership organization, and most of the names that you've mentioned there are members of IDS. So we take best practice from the country and build it into the system. There's certainly a discussion to be have with yourself, because I'm well aware of the work that you've been doing in Christchurch. But ultimately, we then take best practice and we roll it across the country. So the water system that we currently got, the potable water system, was built 8 years ago in collaboration with Dunedin City Council and WSP. But we've got the other consultants, most of them, as part of, and contractors as part of our membership organization.
For Purvey, you were talking about invert levels
Yeah.
and downstream higher than upstream. I'd point out that we do not have pipe invert levels, and very few councils will.
Yeah, this is again a compatibility issue when we compare the data coming from councils versus
Yeah,
transferring it to the board of.
but considering the source of the information, the pipe invert level has never been measured. What has been measured is the manhole invert level. And what you haven't identified is is it a entry overflow pipe halfway up the manhole wall, or is it a invert level departure? So you've got the pipe type field there. I'd suggest you pull out all the pipes that are marked overflow, and they should all be backwards. And what do you mean by performing?
Performing in what context?
You mentioned how pipes are performing, but you were talking about deterioration at the time.
Yes, okay, so if you go back to that classification system, you will see that, I mean, in most asset groups, you have got performance of the condition aspects of the pipe. You've got the level of service performance to the customer, so it's pressure and those sort of aspects. And then you've got, just to name a few.
Yeah, I'm just making a point that it's not just the pipe attributes we have to be careful what we call them.
Yes.
It's also what we're talking about. Because we're talking about condition deterioration, whereas performance, I keep having councillors coming to me asking about pipe performance, and I keep telling them we don't measure it.
Point that I said, people call the same thing different names.
Yeah.
And what we're trying to establish, because also people talk about defects and failures interchangeably, and actually it's not the same. So what we've tried to do with this paper was to standardize it and just make the definitions clear. And yes, I do encourage you to look at that and give us feedback on that, because that is going to be a foundation for the further work we're going to do.
Yeah, have you tried to align it with the LIN's data standards? Because they've got fairly national standards for what we call what thing.
That's one of the data sets we get looked at.
It's were developed from the Lean standards. Were developed from the Lean standards. Sorry, Mike, I just have to be aware that we are getting close on time. So I just wondered if there's some things that might be done offline with teams. Because they'd love to talk to you. One more.
In terms of John Black's work and the water care work with samples, we've just stopped doing that because we think it gives us a completely skewed view. You're only collecting your samples when there's a failure.
Correct. Yes, yeah, well aware of that, but I think there is still value in picking up that. Now, but I'm aware of that.
Yeah, Brendan Harkness here from Watercare. Thanks for the presentation, and I think you might have been referring to two separate sort of projects, possibly under Quobus, the FUNSIL as well. So there's quite a few different research projects happening, the CCTV, and then the analysis of pipe failures are underway, but I wouldn't say they're sort of comprehensive and that they're necessarily going to skew our information. Definitely, helpful to inform. Is there time for a question, Greg, or are we out of time?
Are you Brendan always?
Oh, no, just, only if you got to. I guess it was more,
this time, yeah.
It was more a question about the quality portal that you kind of talked through. I guess picking up on that similar comments around inverts, and it's probably no surprise to any utility owner on the call or in the room that you've identified these challenges. That's fairly well known. I guess the question is, how can that system help to start to make sense of that data, as opposed to, I guess, the first pass is identifying the anomalies and exceptions?
Yeah, I think that's got two components to it. I mean, first off is when there's an anomaly identified, and it can be traced back to the way that the data was recorded in the first place. It may not be wrong, and then perhaps the rules have to take account of that, versus identifying something that is truly at fault and need to be corrected within the data set. So as we keep on using the system, it's very similar to the registry that we've got in the data portal when we map to the data standards. It's a registry that's growing with time. With every council coming in, you always find something you haven't thought about before. And with that, then it makes the overall checking system just so much richer.
One last one.
There's a question there.
There's one on the chat as well, Greg.
Yes, my name's David Lynch. I act as an advocate and a lobbyist, and I have a specific interest in lessons learned from the earthquakes and engineering, also as an intensification. So my question is around the issue of intensification in terms of will the information that you capture be able to give bureaucracy an immediate answer that their expectations around intensification in a given area won't be achievable because the infrastructure is not available to service the intensification?
Yeah. So the question to that is no, not as it is. What we have provided is the data for the further analytics and decision making to happen. So obviously, to answer the intensification and the densification question, you have to run a capacity model on that, which we don't have in this, but we provide the data, the inventory data that fits into something like that. Good. Am I off the hook? One more.
Barry, I'm lucky last. Dave Pinkley, Christchurch City Council. One of the interesting things about the analytics that you've used on Power BI for attributes, etc., we've done something very similar. And one of the interesting things that we found is if you just look at fields being filled, then yeah, if there's something in there, you know, boxes ticks and moved on. So we've started now leveraging our geospatial information, so our corporate data sets, into that 3D digital world with AEC. And it's really, really interesting when you start looking at those inverts that the common sense element is missing.
Yes.
So we've got, I think I've said to a couple of people, we've got manholes in Christchurch City that are sitting at an RL of 100. So they're sitting way above, you know, anything. We've also got inverts on pipes that are 9.5, 10 meters deep. So literally the way that the system works at the moment is academia is taking this data and building these models. But we found that it's not getting peer reviewed by engineers or hydraulic asset owners, etc. Just to say, does that actually make sense?
Yeah.
And certainly moving into this 3D space, it's highlight there are so many errors now.
Yeah.
The data looks right
Yeah.
as soon as you put it in 3D world.
So
It's wrong.
it's when you start using the data for what it's
That's
intended to
correct.
do that you pick it up. We've done with our first modeling around for Dunedin. There was a neighborhood that came out, everything almost need to be replaced now. And then when we went back to the data, the install date was 1909 instead of 1999. Yes. Yes.
Yeah.
No, I fully agree with that. So yeah, it's I guess an ongoing process to pick up those things and get them fixed.
Brendan,
But
hi.
in any case, our data quality tool is available for anybody who wants to look at it and comment on it. It's just going to improve on the overall outcome. Thank you. Correct, that's me.
Yes, I think so.
Thank
Thank
you
you very
very
much. Thank you, James. Thank you, Trevor.